Hey everyone, it's Mr. Glover checking in here. I'm about to do the next video lesson. So the topic for today, chapter 5.4, it's on determining restrictions on composite functions. So basically, we're going to be building composite functions that might be slightly more involved than last time. And we're going to be finding domains and ranges on them. Essentially, the strategy is going to be to build the function, try to find the domain if you can by hand, and then we're going to need to graph things to find the ranges. So yesterday we discussed how to form composite functions. For example, for f of g of x, we're going to start by writing out f of x. We're going to replace x with original equation, or in the original equation with g of x, and then we're probably going to have to simplify it in the end. So let's build a few functions. First of all, we're given f of x equals x squared minus 5x, and g of x equals 1 over x plus 2. So we need to build f of g of x. I'm going to do that by writing f of x out, but I'll leave brackets instead of x. So this is going to equal, bracket squared minus 5 times bracket. And in those brackets, I'm going to write g of x. 1 over x plus 2, and 1 over x plus 2. Now we need to simplify this a little bit. 1 squared is just 1. And our denominator, we could expand our brackets, but we can also just leave it as x plus 2 all squared. And then for this one, it's going to simplify to 5 over x plus 2. Technically, we could expand the brackets and do another line, but this is enough to get the composite function. Let's move on. G of f of x. So g of x is 1 over x plus 2, so I'm going to write 1 over bracket plus 2. And then in those brackets, I'm going to write f of x, x squared minus 5x. And then I'm going to try to simplify this. In this case, the only simplification that we can do is remove our brackets. So this will become 1 over x squared minus 5x plus 2. All right, and the last one, f of g of x, or f of g of 2. So we've already made f of g of x. We know what it is. It's this equation up here. So what we're going to do, I probably should highlight this. What we're going to do is we're just going to replace x with 2. So I'm going to go 1 over bracket 2 plus 2 all squared minus 5 over 2 plus 2. We'll end up with 1 over 4 squared minus 5 over 4. And then this becomes 1 over 16 minus 5 over 4. I'll have to continue over here. 1 over 16 minus, we need a fraction with a denominator of 16, so we could call this 20 over 16. I just multiplied 5 over 4 by 4 over 4. And then lastly, we simplify by subtracting negative 19 over 16. All right, so question D is the tricky one. This one is asking us to find the domain and range of f of x, g of x, f of g, and g of f. So let's kind of split this up a little bit into our 4 functions. We'll split it up into f of x, g of x, space it out a bit more, f of g of x, and lastly, g of f of x. All right, so basically, we're going to do 2 things. The first thing we're going to do is we're going to look for fractions or square roots in the function, because this will give non-permissible values. And the other thing we're going to do is we're going to have to graph both functions. We'll graph all functions. Graph function to find the range. All right, so for f of x is the first one. X squared minus 5x. I don't have a fraction and I don't have a square root. So I'm not going to have any restrictions on x. I'm allowed to put any x value into this function and it will still work. So as far as my domain goes, x is going to be in the reals. However, my actual range, I don't know, because the range, because it's a parabola, it's either going to open upwards where the range is got a minimum value, or it's going to open downwards where the range is going to have a maximum value. But we're going to have to graph it to see. I know because it's got a leading coefficient that's positive, it's probably going to open upwards, but we don't know what it looks like, so we need to graph this. So the function x squared minus 5x. You can use a graphing calculator or Desmos. X squared minus 5x, and it is a parabola that opens up. Looks to me like it has a minimum value of negative 6.25. So if I go back to my question, y is going to be everything bigger than that. So my range is that y is greater than or equal to negative 6.25. All right, let's move to g of x. G of x is 1 over x plus 2. So we do have a restriction here. We can't have a 0 in our denominator, so x cannot be negative 2. So for our domain, x is all real numbers except x cannot equal negative 2. Our range, however, we need to graph it. Now technically we've done these functions, we should know what they look like, but it's not a bad idea to actually graph anyways. So it's 1 over x plus 2. Let's go down to one over x plus 2. And now my function has a horizontal asymptote at y equals 0, but otherwise the function keeps increasing forever and decreasing forever. So y is all numbers except for 0. So if we go back, we can change our range now. Our range is that y is all real numbers, except y cannot equal 0. Okay, f of g of x. So we built the function first. This will help us. It's kind of an ugly function, and I don't really know what the shape's going to look like. I do know, however, that I've got fractions, and that the denominators of those fractions are x plus 2. So I know that x cannot equal negative 2. So for my domain, x is all real numbers, except x cannot equal negative 2. I'm going to have to go and I'm going to have to actually graph this thing though. So it's 1 over x plus 2. Oops. 1 over x plus 2 squared minus 5 over x plus 2. The function looks a little something like this. It looks to me like it has a horizontal asymptote, so it's not going to have a y value equal to 0. However, it does actually cross right here, so it does equal 0. It looks like it's increasing, and we can confirm that by zooming out, and it is. But it does also have a minimum value. Our minimum is, again, negative 6.25. So if we go back to our question, y is all real numbers, except y cannot equal, or sorry, except y, let's change this. Y is greater than or equal to negative 6.25. And again, this number popped up earlier. Lastly, g of f of x. So g of f of x is 1 over x squared minus 5x plus 2. We've got a couple of ways we can handle this. We can set our denominator equal to 0. and we can try to factor it, or we can try to use the quadratic equation. However, if we're going to be graphing it anyways, if we need to find the range, we can figure out where our x values don't exist, or we should be able to figure out where our x values don't exist. So let's graph this. So the function itself is 1 over, oh man, 1 over x squared minus 5x plus 2. It looks something like this. Now, I can see my vertical asymptotes are going to appear at places where x can't exist. It looks to me like we're getting ever so close to x equals 0.4, but we're not passing it. We can zoom out, we can click down here, and yeah, x equals 0.43 roughly. And for our other one, 4.5, yeah, 4.5. So we'll use 0.43 and 4.5 as our vertical asymptotes. It also has a horizontal, or sorry, it has a horizontal asymptote at y equals 0. So we've got some restrictions here. Going back to the question. For our domain, x is in the reals, except x cannot equal 0.4, approximately 0.43, or 4.5. And if you want a more exact value, you can simply use the quadratic equation on your denominator to figure out where it equals 0. As for our range, y is all real numbers, except y cannot equal 0. All right. So when finding the domain and range of composite functions, you have to be careful not to overlook any restrictions that may arise. You have to consider domain and range of both the original functions. So we'll call them the inner functions and the outer functions. For example, if we had something like f of x equals 1 over x as our outside function, we would have a restriction that x cannot equal 0. If we had, let's pick an inner function, let's go x plus 6. G of x equals x plus 6. That function doesn't have a restriction on x because there's no fractions and no square roots, so x is all real numbers. But when you go to make the composite function f of g of x, we're going to get 1 over x plus 6. And now this is going to be a little bit different because x can equal 0 and we'll get 1 over 6, and that's fine. But x can't be negative 6. If we have that, we'll have a divide by 0 issue. So x cannot equal negative 6. Otherwise, x is in the reals. So you've got to look at the outer function. You've got to look at the inner function. Sometimes we will see a restriction carry forward from the outer or the inner to the composite. And we saw that where y was greater than or equal to negative 6.25 in f of x and f of g of x. However, sometimes when we build the composite function, it changes the way that the function is laid out, and we've got to look at our denominators or our square roots. So you would think that the domain and range of the outside function would dominate over the inside function, but this is not always the case. It helps to think of the inner function as an input value for the outside function, and I'll show you exactly what I mean for that. So the domain and range of f of x, we've got the square root of f of x equals the square root of x. So if we want the domain of that, we can't have a negative in our square root, so x must be greater than or equal to 0. As far as our range goes, if we were to graph this, square root functions always take a similar shape. If we were to graph this, we would get this. So for the range, y is greater than or equal to 0 as well. G of x, however, is going to be a totally different beast. G of x is x plus 3. If we were to graph this, it's going to be a straight line with a y-intercept of 3. There's no restrictions on x. X could be any real number. However, y can also be any real number. But when we do f of g and g of f, that's going to change things a little bit. So let's split this up. We'll go f of g on the left, and we'll do g of f on the right. So now f of g of x is going to be the square root of brackets, and in the bracket will be x plus 3. So this is going to be a slightly different function. Now we can graph this, but we should be able to graph this one without a graphing calculator. This is going to, again, be a square root function, but it's been translated 3 units to the left. So instead of starting at 0, it's going to start over here. As far as the domain goes, x is anything past the point 3. So x is greater than or equal to 3. And our range is anything above 0, so y is greater than or equal to 0. For g of f of x, it's going to be a little different. G of x was x plus 3. We're going to replace x with f of x, so it's going to become the square root of x plus 3. And so in this case, we have an x inside our square root, and that's the only thing giving us a restriction. We can't have negative square roots, so x itself can't be negative. So x must be greater than or equal to 0 this time. Our y values, if we look at what this thing looks like when we go to graph it, this is, again, a square root function, but the translation's not 3 left anymore, it's 3 up. So instead of starting here at 0 and 0, it's going to start here at 0 and 3. It doesn't affect the x values, but it does change our y values because now y is greater than or equal to 3. And so it would be nice to come up with one easy rule that applies every time. Like, you always have the same restrictions as f of x, but it's simply not the case. You're going to have to build the function. You're going to have to use the shape of or the form of the function to figure out the domain, and you're going to need to graph it to figure out the range. Unless you're really, really good at making tables of values at the exact right spot, you're going to need to graph this. So one more, well, actually 2 more. Given that f of x is 1 over x minus 2, and g of x is x squared minus x, write an explicit equation and state the domain and range for the following functions. So we're going to make g of f and f of g. G of f of x is going to equal bracket squared minus bracket. And in those brackets, we're going to write f of x. So it's going to be 1 over x minus 2 squared minus x minus 2. Or the function will be 1 over x minus 2 squared minus x minus 2. All right, and now technically we can expand these brackets out further. However, as soon as we do that, it's going to turn into a quadratic, and we're not going to be able to quickly tell what our domain is. If we instead leave it in this form, the domain and range are a little bit less painful to do. Our restrictions are coming from fractions. So we look at our denominator, we look at the bottom of this fraction. It's x minus 2 all squared. That's going to give us a problem if this equals 0. So x can't be positive 2. Then we'd have 2 minus 2, which is 0. So I know right away, x is all real numbers, except x cannot equal 2. If I had expanded my brackets, I wouldn't have been able to do that as easily. And then our range. And now the range is not something you're going to be able to figure out just by inspection. You're going to have to graph it. So pull out Desmos or your graphing calculator, and let's graph this. So the function is 1 over x plus 2 all squared. Minus 1 over x minus 2. So now this is a really strange looking function. We've got y values that approach 0, but they don't quite reach 0. We've got 0.75 here. Our function seems to be increasing really rapidly. And it looks like it's decreasing really rapidly. So then the question becomes, are there any y restrictions? Is there anything we can't make with this function? If we trace this, it gets increasingly close to 0, but never actually equals 0. On our other side of our function, it gets increasingly close to 0. But again, I don't know if it is actually going to equal 0. It doesn't appear to cross the x-axis at any point. Oh, and I might be wrong. It's negative. No, it's not crossing. It's getting infinitely close, but it's never crossing the y-axis. So for this function, x cannot equal 0. Y cannot equal 0, but it can equal anything else. It equals all positives and all negatives, just not 0. So our range is that y cannot equal 0. And actually, there is a quick change here. This should be 1 over x minus 2, which will slightly change the function. All right, f of g of x. It starts with 1 over x minus 2. So it'll be 1 over bracket minus 2. And in the brackets, we'll write x squared minus x. So this will simplify to 1 over x squared minus x minus 2. Now, our domain might not be easy to figure out because we'd have to factor this somehow. And it might not factor nicely. We can use the quadratic formula to do it by hand, but we can graph it as well. 1 over x squared minus x minus 2. It looks like this. Now, the y values are not going to equal 0, but the y values look like they're greater than 0. However, they're not exclusively less than. We've got a maximum down here. So the y values get split up. They're either less than negative 0.44 or they're greater than 0. Our x values, we're going to have an asymptote, and it looks like our asymptote is going to be minus 1 and 2. And actually, maybe we could have factored it by hand, but we've got them here. So minus 1 and 2 are the x values that don't exist. 0 can't exist, and otherwise y has to be less than negative 0.44. So if we go back, our domain is that x is all real numbers, except x cannot equal 2, and x can also not equal negative 1. As far as y goes, y is going to get split up. So y can either be strictly greater than 0, but it can't equal 0, or y will be less than or equal to negative 0.44. We can ensure our domain and range is correct by graphing. All right. So now these are hard questions. These are the kinds of things that you can expect to see as the challenging types of domain and range problems. It's not going to be every time that you have to split your y values into sort of sections. Let's try one more of these. So we've got root x, and we've got negative x squared plus 2x. We need to make g of f and f of g, and define their domains and their ranges. So g of f of x is going to equal negative bracket squared plus 2 times bracket. And then in those brackets, we're going to write root x. So this is going to be negative x plus 2 root x. Now, if we want to find our domains, we've got a square root, and technically we had one here too, but we can just use this one. You can't have negatives, so we're stuck with x being greater than or equal to 0. As far as our range goes, I don't really know what this looks like, so I'm going to have to graph it. X plus 2 root x. X plus 2 root x. This function has a maximum, an absolute maximum at 1. Otherwise, the function can equal 0, and it can equal anything below. So for our range, y will be less than or equal to 1. And then last but not least, f of g of x. So it's a square root was f of x, so it's the square root of something. And in those brackets, we're going to put g of x, so minus x squared plus 2x. So this will equal the square root of negative x squared plus 2x. And I'm going to factor this by hand because I don't really think we need to graph it to find our domain. Actually, we might need to, but we can try. So we can actually pull out a factor of x from both of these brackets. Actually, we could even do a negative x. And then our other set will become x minus 2. So it looks to me like x cannot be equal to 2, because that's going to give us problems. However, we've got this negative x here, and that's going to kind of make things tricky. Because any positive value of x is going to turn this into a negative. So we can solve this by hand, but it's going to be a little bit tricky. It might be easier to graph this one. Technically, we could find a range of values where we get a negative out of the brackets, yet we get a positive out of here, sorry, a negative out of here, and that will multiply together to create a positive. And technically, if we go anything from 0 to 2, we will get a negative value out of our brackets, but we'll also have a negative value here, and that will multiply negatives and create a positive. So technically, our domain is going to be between 0 and 2, but we'll graph it and we'll confirm that. I'll write it down for now, but it is something we should check. So x has a range of values where it's less than or equal to 2 and greater than or equal to 0. So let's graph this. So square root of negative x squared plus 2x. We've got a strange looking function here. it has a maximum value of 1 and a minimum value of 0. And for x values, it goes from 0 to 2. So we were right with our prediction, 0 to 2. As far as our range goes, though, our y value is stuck between 1 and 0. So that is going to be it for the notes today. I know this is kind of weird stuff, and it's probably going to take a bit of practicing, but we followed literally the same process for every question. Build the composite function first. Look for square roots, look for fractions. Those are going to cause restrictions. Use those non-permissibles to figure out your domain. To find the range, you're going to have to graph the function unless you know enough about it to graph it by hand. And that's essentially it. So I've got some questions for you, 3 to 7, A and C, and question 9. That's going to be your homework assignment for today. I'll end the video now, and I hope everybody has a great weekend, and I hope to see you all next week. Bye.